Hello guys, can someone confirm if you are able to hear me? Okay, we'll start in a couple of minutes. Hi Sumit, hi Gargi, Ashish, Saif, Manpreet. Okay guys, let us start the session. So the topic for today's discussion is prefix sum. So let us do a quick summary of what all we have covered till now. So we are studying arrays, and within arrays we have done some basic questions. Okay, and then we started our discussion with two pointer, and we solved some questions on that, and then we did sliding window. And if you observe, sliding window is also kind of a two pointer approach, right? And then we did, I think I did not share my screen. Okay. And then we did binary search. And if you observe, binary search is also a two pointer technique. Okay. And today we are going to do another pattern, which is called as prefix sum. Today we will be discussing about prefix sum pattern. Okay, I hope you guys are following all the videos and whatever pattern I'm showing you, and I'm showing you I think two or three questions per video, but I've also given you a sheet where you should be able to practice more questions on the same pattern, right? And these are very very common patterns. Very often you will see questions on these patterns. Okay, so today let us talk about the prefix sum pattern. And I will not go into theory of what is prefix sum. Let us directly start with a question, and in the form of a question only we will understand. Okay, so if I go to our sheet, this is our sheet, and I think there is a question called this one, 560. So here I've marked it as a sliding window. It is not actually sliding window. It is prefix sum. Okay, so let me go to question number 560. And let us read the question, and then we'll try to think of an approach. Okay. So here's the question. The question says that we will be given an array of integer nums and an integer k. Fine. And we need to return the total number of subarrays whose sum equals to k. So I hope all of you guys are able to recall uh, the concept of subarrays. We did this question in sliding windows. And I told you what is a subarray, contiguous part of array, or subarray by itself, the definition subarray, a portion of an array. Okay, contiguous. Okay, whose sum equals to k. Let us look at an example. Say for example, we have been given this 1, 1 and 1, and we have been given target. So target k is 2. So we need to return how many subarrays of this nums array will have sum equal to 2. Okay, so how many subarrays are possible, and what is the brute force solution to this, and what would be the time complexity of that brute force solution? So you can say that, sir, one subarray is this. Okay, just one. And then another subarray is this 1 and 1, and this 1 and 1 is having a sum of 2. Okay, so our answer is definitely 1, because this is one subarray, this is 1 and 1. And then we can expand it, and this is not a valid subarray. Then we can start from this, and we can say this is not a valid subarray, but this is a valid subarray. So we are getting again 1 and 1. So we are getting two subarrays whose sum is equal to 2, and therefore the output is 2. Did you guys get it? Did you guys understand the question? Here we also have a definition of a subarray. So it says the subarray is a contiguous non-empty sequence of elements within an array. Okay, so contiguous is the important part here. If it is not contiguous, then it becomes a subsequence if it is in the sequence. Okay, so what are possible approaches to this question? Let us go to our notepad and try to explore this. 560 subarray sum equals k. Okay, so this is Leetcode 560 subarray sum equals k. And let us take an example. Let us take 1, 2, 3. So we'll be given an array nums. This is 1, 2, 3. Let me say 2 and 1. Okay, or let us take a simpler example. Let us just take 1, 2, 3. And what is the value of k? The value of k is 3. Okay, so k is equal to 3. So we need to find number of subarrays whose sum is equal to 3. So what would be a brute force solution, guys, to this one? Should the elements be unique in every case? F, no, no such thing is mentioned in the question about unique. They told us that they will give us an array which will have integers. Okay, unique or not, that is not mentioned, and it's a pretty straightforward question in terms of understanding the question. It is pretty straightforward. So this says that out of these, out of all the subarrays of this 1 to 3, how many are having sum is equal to 3? So what is the brute force solution? If you remember, the brute force solution will be that find out all the subarrays and then keep track of the sum, and whenever you get a sum equal to 3, then you increase the counter, right? Or if you are asked to return the subarray, then just return the index, keep the index in a element. So what are the possible subarrays? We will start with 1, so we'll say 1 is a subarray, and then we can say 1 and 2 is a subarray, and then we can say 1, 2 and 3 is a subarray. Out of these, this is a valid subarray, correct? This is having a sum equal to 3, and then we can again start from 2. 2 is a subarray, 2 and 3 is a subarray. Okay, and these are not valid, and then we can start from 3. Okay, and there is nothing, and 3 is a valid subarray. So the answer that we have here is 2. We got two subarrays whose sum is equal to 3. Okay, so this is the brute force solution, and what will be the time complexity of this? By now you should be able to tell that this is going to be O of n squared, because we are going to explore all the elements for 1, and then all the elements for 2, and then all the elements for 3. So roughly it is going to be quadratic O of n squared. So our baseline is O of n squared. Okay, our baseline is O of n squared, and I told you if you want to go from O of n squared, if you want to optimize it, and it is an array question, definitely our first approach has to be O of n. Okay, there is no sorting or there is no such intuition coming for binary search, therefore we cannot attempt for a log n. You can think about n log n. Again, n log n is not coming intuitively. The first thing that is coming to our mind is that we can do O of n. Now I told you that if you want to do O of n, from whatever we have learned so far, you could ask me that okay, O of n, then we can probably go with sliding window. Okay, sliding window approach. Two pointer approach also we can say, but that is also apparently sliding window only. Okay, so you can say we can do sliding window, sir. Okay, fine. So we can say nums is equal to 1, 2 and 3. Okay, and we will put one pointer here, left pointer, and we will increase the pointer we'll have a right pointer here, and we will increase the right pointer, and we will add the sum. This will be a variable sliding window problem. So we'll put it here and we will increase the sum from 1 to 3. And if that is a valid window, if this is a valid window, sum of the window is equal to 3, then we will increase the counter by 1. Okay. And after that, we will increase the window further. We'll increase the window further and it will violate it, and then we will decrease the window. Okay, it is still more than 3, so we'll further decrease it, and then again we will get a window which will be having 3, and we will be able to add this window to our answer, and our answer can be 2. So this is the basic of sliding window which we have discussed so far. So if you're getting this intuition of sliding window, that is great, but there is a small problem in this approach. Okay, and I think I mentioned that approach when I was talking about sliding window. uh, you can go and check in the notes somewhere. I have mentioned it. Let me go up and see somewhere. See, here I told you one thing here, that this is possible only for positive integers. And if you read this question, when we did question number 209, if we go and if we read this question, you will see that in the constraints section, it has been told to us that these integers are going to be positive. Okay. Why it is important that these integers should be positive, and what is the issue if we don't have positive integers? Okay. The issue is that when we are working with a sliding window, we are assuming we are assuming that when we increase the window only in case of positive integers, and this question was actually asked in an interview, so I'm talking from my personal experience. Okay, so only in case of a positive integers, when you expand sliding window, the sum will increase, and when we shrink sliding window, the sum will decrease. This is possible only in case of positive integer. So when you have when you have expanded your sliding window and your sum has increased and you want to decrease it, so you will shrink it. But if there are negative integers, then this is not possible. This is not guaranteed. So this approach is not going to work if we have negative integers. This does not work. I hope you got an understanding of why sliding window will not work. Does not work if there are negative integers. So this you have to keep in mind. Okay, guys, this you have understood. So far, I have not told you what is going to be the solution, but we know that what is going to be a brute force approach, and what is the first thing that will come to our mind, which is sliding window, and because of the constraints, why this is not going to work. So if I show you the question, you can see here there is a constraint. If you come to the constraint section, you can see that nums can be between -1000 to +1000. Okay, this is the constraint where you have to see. Okay, all of you are with me so far, guys? So then what do we do? So we use an approach which is called as a prefix sum approach. So what does the prefix approach sum tell us? Okay, first I will tell you what is the prefix sum approach, and then I'll tell you where it is applied, and it's pretty commonsensical. Okay, all of you will be able to relate to it. It's not something new, just that the application to a particular problem, that is something that you will find insightful. Okay, so the prefix sum basically says that if I have an array called 1, 4, 3, 6, 8, 2. Okay, suppose this is nums, and if I calculate the running sum, if I calculate the running sum from here, okay, if I calculate the running sum from here, so if I say that the running sum or sum of all the elements up till here is 1, and till here is 5, and till here is 8, and then till here is 14. Okay, and then 14 plus 8 is 22, and then 22 plus 2 is 24. Okay, this is the running sum, or we say this is the prefixes. This idea you must have seen somewhere in cumulative sum, also come some, if you're learning a little bit about statistics, or if you have done some data mangling, you would have come across this concept where we take the running sum. Okay, now the idea here is that idea here is that and I'm not relating it to the question, I'm just giving you some intuition of prefix sum, and then we will come to the question. Okay, that if we have this, if we have calculated this, okay, how does this, what does this help us with? This helps us in generally speaking, this helps us to find out sum of any sub array. Okay, any sub array in this nums. For example, if I tell you that I want to find the sum of this window, okay, I tell you that I want to find the sum of this window. Okay, okay, so if I am able to find out this much sum, okay, this much sum is stored where? Here. Okay, and if I am able to find this much sum, this much sum is stored where? Here. Okay, and if I am able to subtract that, okay, then I will get the sum of this window. Is this idea clear? In fact, this is the basis of one more question that we will do later. I think we should have done that question first, but I hope this much is clear to all of you. If this is clear to all of you, then let us try to relate it to the question that we have. Okay, so we have nums is equal to 1, 2 and 3. Okay, and the value of k is equal to, was it 3? 3. Okay, so if I look at 1, 2 and 3, if I look at 1, 2 and 3, okay, and if I ask you that if there is any subarray, if there is any subarray, is there any subarray, or how many subarrays are there which are ending with 3, or let us start with 1, how many subarrays are there which are ending with 1 whose sum is 3? You will say none, because there is no element on the left hand side, so there is no such element. Okay, so we will say that we'll create one dictionary here, and we'll say that we have seen the sum 1 one time. Till now we have seen the sum 1 one time. Okay, and I will take this and I will bring it here. Okay, and I will ask you how many subarrays are there which are ending with 2, which is having the sum equal to 3. How many subarrays are there? In this case, there is only one possibility, because there is only 1 and 2, but when we go to 3, at that time you will see the difference. Okay, so if this sum has to be 3, if this sum has to be 3, if we want this sum to be 3, it means, or this is a too short an example, I should have taken a bigger array, but the point is that if this sum is supposed to be 3, okay, then we should have seen a bigger, the target minus this value, or no, this is, I'm taken a very short example. uh, okay, if this sum if this sum is 3, or let me take, you will not get the intuition here. Let me take the intuition here. Okay. If this is 3, okay, so sum till here is 3. Okay. Sorry, the sum till here is 6. The sum till here is 6. Okay. If there is any subarray, if there is any subarray in this range, if there is any subarray in this range with the prefix 6 minus 3, okay, or I will say current sum minus target, okay, if this prefix sum is existing before this, which means if there is any element this much which is having current sum minus target, okay, then this will be how much? This will be target. Why? Because this whole thing is what? Current sum. If we are able to find out, if we are able to find out this value, current sum minus target, if we are able to find this value, okay, if we are able to find this value, which we can find using this dictionary, okay, if we are able to find that, that means this target is existing. If current sum minus target is present, that means the remainder of it will be target. So how many ever prefixes are having current sum minus target, that many prefixes will also be having target. Is this intuition clear? What I said, this might be little confusing for some of you. I will take a bigger array example and I'll show you. But did you understand this part? So what we are going to do is we are going to keep track of the prefixes. Let me do a dry run on this. Okay, I'll say 1 I have seen one time. Okay, okay, and I will come here. What is the current sum? The current sum here is 3. Okay, so if this sum is 3, then I need to find out, okay, how many sums are having target. 3 minus 3 0. Okay, so here we start with 0 as 1. We have seen one time. This prefix sum is basically how many times a prefix is seen. Okay, so I'll do a dry run, maybe then you will understand it better. So we start from here and we say that 0 sum we have seen one time, so we'll say 0 is seen one time. Then we'll come here, okay, and I will ask the question that my current sum is 1. 1 minus 3 is equal to minus 2. Have I seen minus 2? I have not seen minus 2. Okay, so I'll say I will not do anything and I will add 1 to my dictionary and I will move ahead. I'll go to 2. Okay, and I will say that have I seen 2 minus 3? 2 minus 3 is minus 1. Have I seen minus 1? I have not seen minus 1. So I will add that, okay, I have seen 2 one times. Not 2, sorry, 3. The sum here is 3, no? 3. Here I will ask the question, have I seen 3 minus 3 is equal to 0? Sorry, I misspoke earlier. 3 minus 3 is equal to 0. So I'll say yes, 0 I have seen one time. So I'll say count is equal to 1. And this is actually a valid subarray. Okay. Then I will move my pointer here. Okay. And I will come to 3 again. I'll come to 3 again. Again, I will ask, sorry, not 3, 3, 4, 5, 6. This total current sum we have to take. 6 minus 3 is equal to 3. Have I seen 3 in this dictionary? I'll say yes, I've seen it one time. So I'll add 1 here and the answer will become 2. Did you guys understand this? Should I explain it one more time? Dry run. I misspoke once. I'm sorry about that. But did you get an idea? Let me take another example. Let me take 1, 2, 4, 6 like this. And let me say that my target is equal to 6. Okay, I will say my target is equal to 6. So what I will do? I will start with a prefix sum. Dictionary I'll make, and I will say that I have seen the sum 0 one time, which is here. Okay, and then I will bring it here. Okay, and I will say what is my current sum. This is my current sum minus target. Okay, so what is my current sum? Current sum is 1. Target is what? Target is 6. So I'm looking for minus 5. Have I seen minus 5? I have not seen minus 5. Fine. So I'll add my current sum to my prefix sum. I'll say I've seen 1 as a prefix sum once. Okay, and I will move ahead. I'll come to 2. What is my current sum? My current sum is 3. Okay, what is my target? My target is 6. What am I looking for? I'm looking for minus 3, which means that if I have seen minus 3 somewhere, if there were some elements here and the sum was minus 3, okay, and this total was 3, 3 minus 6 minus 3, okay, then this side I would have seen something which is 6, which I want, okay, but so far we have not seen it, okay. So 3 minus 6 minus 3 we have not seen it, so I'll add 3 here, 1. Okay, what does this prefix sum is representing? It is representing wherever I am currently up till that point. What are the sums we have seen? So we have seen 0, we have seen 1, and we have seen 3. 0, 1, and 3. Okay, and then I will again move ahead. I'll come to 4. Okay, my current sum is what? 4 plus 2, 6 plus 1, 7. 7 minus 6 is equal to 1. Have I seen 1? Yes, I have seen 1. So my count is equal to 1 now. And does it make sense? Why? Because if this much is 7, okay, and I'm looking for 1, okay, and this much is 1, which means this much is 6. And actually, if you look at this, this is 6. Are you getting, guys? Only this much is prefix sum, nothing else. If you have understood this, then you have understood prefix sum. There is nothing more. Okay, so we have seen 1, and where was our pointer? Our pointer was at 4. So I'll move the pointer now to 6. Okay, so what is my current sum now? 13. My current sum is 13. And did I add the value? I have to add, no? Last sum was what? 7. So we have seen 7 one time. 4, 5, 6, 7. This 7 we have seen one time. So 13 minus 6 if we do, how much do we get? 13 minus 6, 7. So I'm looking for 7. Is 7 in my prefix sum? Yes, it is there. Which means what? That this total is 6 plus 4, 10, 13. This total is 13. And this much is 7, which means this much is 6. And it is actually 6. So I found one more answer. So count is 1 plus 1. So the total answer is 2. Did you guys understand the approach? Guys, please tell me in the chat. The whole idea is basically that you have a running array. There are so many elements here. Okay. And at any given point of time, you are here. Okay. And this total sum is my current sum. Okay. And in this current sum, I'm looking for any subarray whose sum is equal to k. So if there is any subarray, this one, whose sum is equal to k, then this much is going to be current sum minus k. This is actually a prefix, and I'm storing all the prefixes. This current sum minus k, this is actually a prefix. All the prefixes are stored here. So if this is existing, if we have found this, which means this also has to be true, and I'm interested in this. And I'm not interested in the array, I'm just interested in how many are there. So that count is available here. So at any given point of time, if I find this current sum minus k, then this k is also present. I will just increase my counter. This is the only maths behind prefix sum. Okay, chalo, let us now write the code. I hope I've explained it in a lot of detail. You should be able to write the code. Let me zoom out. Anyone has any question, please mention it in the chat. Let me look at the chat. Sir, can you move your speaking window to the left top? View of your writing is not seen. Okay, sorry. Let me reduce my window. Is this fine? Guys, I'm looking at the chat. I think all of you, none of you have any doubts. So what we'll start with, we'll just say that we want a prefix sum, or let me say prefix seen as a dictionary. Okay, you can use as a dictionary, you can use default dict, whichever way you want to write. And I will say that my count till now is 0. Okay, or result count, whatever you want to say. Okay, and I will initialize my pointer. I'll say write is equal to 0. Okay, and I'll say while, you can use a for loop also, while write is less than length of nums. Okay, so I want to iterate till the last value, and I will say my prefix sum, okay, of, let me say, my current sum. Prefix seen, let me add 0 and 1 here, because this is by default, it will be present all the time. And I will say my current sum is equal to, my current sum is equal to current sum, let me say my current sum is equal to 0. Let me initialize just like this, and I'll say my current sum is equal to current sum plus nums of right. Okay, and I'll say prefix sum of current sum plus equal to 1. Prefix sum of current sum plus equal to 1. Prefix seen, sorry, not prefix, this will be prefix seen. Okay, it will not work like this. We can say, I should have used a default dict, but I can say prefix sum current sum is equal to 1 plus, I want to increase the counter by 1. So I'll say prefix seen, because the key may not be present. Okay, if the key is not present, then it will give me a key error. So I can say dot get current sum, and if that is not present, then it will return a default value of 0. Now this returning default value of 0, you could have used a default dict. Okay, so this is there. Now we can say if my current sum minus my target in prefix seen, then I will just increase my count, and my count will be increased by how much, whatever the value we have seen. Okay, how many ever times that current sum minus target we have seen, that many number of times I will increase my count. So I'll say count is equal to count plus my prefix seen, and how many times I've seen that, I'm storing that in current sum minus target. So I can take this and say current sum minus target. Okay, and I should not have used a while loop here, it's a bad choice, but okay, fine, I started with while loop. Right is equal to right plus 1, and let me return count. Let me run and see, I might have made some mistake. target. Okay, it's not target, it is K actually. So this seems to be working, although this is not the very good way to write. It is failing in one case. Nums1 k is equal to 0. Prefix sum current sum is equal to sum plus nums of right. Good. Count is equal to 0. Current sum is equal to 0. Prefix seen. Current sum is equal to current sum plus nums right. Prefix sum. I think if I have misplaced this. I think that value of 0 was getting overridden by 1. So we need to do addition later and then add first. Okay. Just do a dry run, you will get it. Okay. You can also use a for loop here. You could have used a for loop, but I started with a while loop. So wrote it, but I hope this solution is working. So this, what is going to be the time complexity of this? The time complexity as expected is O of n. Okay. And space complexity, we are using one prefix dictionary. So that is also O of n. Okay. Prefix will be as long as the sum. Yeah. So worst case, it will be O of n. Guys, did you understand this? Increase the font size. Okay. You can do a dry run on this. Okay. You can do a dry run. I'll suggest that whenever you write this code, try to dry run it line by line. So if you have 1, 2, and 3, and you will have a prefix dictionary. So prefix seen is empty, count is equal to 0, right is equal to 0. So right is here. Okay. And prefix sum seen is equal to 1 plus prefix seen. So prefix current sum is equal to 0. So 0 will come as 1 after this line. And current sum will become current sum plus nums of right. Okay. And this line will not run. After that, current sum will come here. Current sum will become, and this value next time will come as 1, will come as 1, and then again you will check 1 minus 3, minus 2 is not present, like that this whole thing will run. Okay. Use a for loop. Okay, don't use a while loop here. I made a mistake. I started, so I completed using that. Should we do another question, same concept? Rajesh is asking, can I explain it from line number 13? Line number 13. देखो ना लाइन, आप इसको ड्राई रन करो, आपको अपने खुद ही आ जाएगा. Suppose this is 1, 2, and 3. Okay. Right is at 0. Okay. And your prefix is like this, and your count is also equal to 0. Okay. So prefix seen of current sum, what is current sum? Current sum is 0. Okay. Will become 1 plus prefix sum current sum 0. So this will give me 0, and this will give me 1. So current sum is 0. So this will be equal to 1. Okay. And then current sum will become current sum plus nums of right. Okay. So current sum is 0 and nums of right is 1. So now my current sum is equal to 1. Okay, and 1 minus k is present in prefix in 1 minus k. 1 minus k is what? Minus 2. It is not present, so this line of code will not run. Okay, and right will come here. Okay, again we will do prefix sim of current sum. Current sum is as of now 1, so we'll add 1 as 1, and then we will check, and then we will increase the current sum. So current sum will become 1 plus 2, which is equal to 3. Again we will check current sum minus k. 3 minus 3, k is 3. 3 minus 3 is 0. 0 is present here. So we'll say count is equal to count plus this value will be 1. Okay, so count has become equal to 1, and again we will go right is equal to right plus 1, so right will come here. Okay, we'll check prefix in, you will be able to run it now. Let us do another question which is much simpler than this. Okay, I should have actually started with that one, it occurred to me later. Let me put this question in your collab document so that I'll share this with you. mm, I will add one more section here. I'll say prefix sum. Okay, I'll add the code later and I will give you. Let us do another question. Okay, so next question, let us do this one. Question number, let us do question number 12. This is much simpler. Sorry, this is question number 303. Oh, we are already delayed today. We have done only one question. Okay, at least let us try to do two questions. Okay, so this is question number 303, range sum query. This is this is the actual solution of the concept that I told you here. This concept, this is a direct application of that. So let us read the question quickly. Okay, so question is range sum query immutable. Given an integer array nums, okay, we will be given an integer array nums. Handle multiple queries of the following type. On that array, we need to run some queries. What are the queries? The queries can be that calculate the sum of the elements of nums between indices left and right, inclusive where left is less than right. The question is saying that I will give you some numbers, say 1, 2, 3, 4, 5, 10. Okay, and I will give you some indices. Maybe I'll give you this index left, and I will give you this index as right, and you need to give me the sum of this. You need to give me the sum of this. Is it not the same as the explanation I gave you? The very reason we use prefix sum is that if we calculate all the prefix sum, then for any sub array we will be able to calculate. So basically, if we want to calculate this, then what we can do? We know this sum and we know this sum, and if we subtract that, then we will get this sum. That is all we have to do. So this is the query that will be run on that array, and we need to design it. So this question is of the type where we have to design something, so we have to write the class and the methods. So this type of questions can come sometimes, where they will give you a requirement and you have to design a class for it. So it's not like writing a normal function. There is a slight change here. Okay, and the input and output explanation is also slightly different. So basically, you see, if you come here, this is the input that has been given to us. If you try to read this input and output, this is the input that will be given to us. So if you read here, the input is -2, 0, 3, -5, 2, and -1. Okay, -2, 0, 3, -5, 2, -1, and these are the indices. Okay, so when we do this, then it has to return nothing, which is basically we are initializing the class, and then some input has been given, which is 0 and 2. So this is 0, 0, 1, 2. Okay, and what is the sum of this much? The sum of this much is 3 minus 2, 1. So the answer is supposed to be 1. Then they are again doing one query, which is 2 to 5. Okay, so if they are doing 2 to 5, that means they are asking us for 0 1 2 2 3 4 5. Okay, so they want us to give us the sum of this much. So this the sum is how much? 3 plus 2, 5 minus 5, 0, and minus 1. So answer is minus 1. So here is minus 1. Okay, and then again they are doing a query called 0 to 5. So if they are doing a query 0 to 5, then 0 is here and 5 is here. So they want this entire sum. So this entire sum is going to be minus 1, minus 6, minus 4, minus 1, minus 3. So this is the answer. I hope all of you understood the question, guys. Did you guys understand did you guys understand the question? This is a typical prefix sum problem. 303 range sum query. So let me come here and do Leetcode 303 range sum query. Guys, all of you are following? Please tell me in the chat. Rajesh ji, Tyler Durden, 1997. Ashish, Manpreet, Dumb Corner XOXO. गार्गी, सैफ, समझ में आ रहा है सबको? इसका कोड डायरेक्ट लिख लेंगे, एक बार एक्सप्लेन करना पड़ेगा. वही अप्रोच लगेगा जो अप्रोच हमने डिस्कस किया, लेकिन उसको थोड़ा सा फॉर्मलाइज कर लेते हैं. Okay, so what we will do, suppose we have been given an array. If we are given an array, then what are the things we'll do? We'll pre-compute the prefix sum and keep it. So pre-computation of the prefix sum is going to take O of n squared, but it will take only once. After that, any query that is made to us, we will be able to respond to that in O of one time. Okay, so if we are having any example, say for example 2, 4 and 6 and 3, suppose. Okay, so we'll calculate the prefix sum. So we'll say 2, 6, 12 and 15. This is our prefixes. Okay, now whenever we are given any I and j, okay, we are given the left and right, what can we say? Whatever is the right pointer, we'll calculate the prefix of right. So that will give us this much sum. Okay, so what we need to do, suppose I'll take an example. Okay, suppose the indices are 1 and 4, suppose. So left is equal to 1 and right is equal to 4, which means left is equal to 1 and right is equal to 4. So we need to find this much sum. For that, what we can do, we can take this much sum, which means prefix prefixes of right minus we need to do this much sum, which is left minus 1. So prefixes of left minus 1. So if we subtract this one, this is prefixes of right, which I'm drawing in white color, and this is prefixes of left minus 1. So if we subtract this, then we will get this, what I'm drawing in pink color. Okay, all of you understood? This is going to be our answer. Or I can say in a better way, I can say sum of This is going to be nums left to right का sum. Okay, here left and right are inclusive. By the way, we have defined it. Left and right are inclusive. This is the whole idea of prefix sum. Guys in the chat, let us write the code quickly. So we will do an init. So when we do an init, basically here we will build the prefix uh, prefixes or pre-calculate, or you can say or pre-calculate the prefixes. Okay, once we have pre-calculated the prefixes, then we will just use the pre-calculated prefixes to answer the query. So we'll build the prefixes. How are we going to build the prefix? I'll say self dot prefix, and I will start with an empty dictionary, because prefix of everything leftwards from the leftmost element is going to be 0. Okay, which we have seen that. Okay, so we'll say for x for num in self dot nums, or not self dot nums, it will be nums only. For num in nums, I'll say current sum is equal to 0. Current sum is equal to 0. For num in nums, I will say current sum plus equal to num. Okay, and I will say self dot prefix dot append current sum. Okay, so if you are having nums is equal to 1, 2 and 3, then self dot prefix will be equal to 1, sorry, 0, 1, 3 and 6. This is what we have done so far. This is what we have done so far. Then what we can do, see, either you can add a 0 here. If you don't want to add a 0 here, then basically you need to take care of the edge case where left is coming here. So if the left is coming here, then prefix of left minus 1 will give you index error. So you can use a if else condition there, or you can add 1 0 for that safety. Whichever one you want, you can do. Okay, so I will use this here, and I will just return my prefixes self dot prefix of right minus self dot prefix left minus 1. Okay, let me run this and see. If I have not made any typo, this should, oh, this didn't work. What happened? 101 1 minus 1 3. So what happened? Self dot right, it should be right plus 1. Why it should be right plus 1, guys? Tell me. I hope that is a mistake. Ah, worked. Why it should be right plus 1? Right plus 1. Uh, Adding plus 1 to the indexes, to the index, because the prefixes, because self dot prefix has one extra 0. I don't know if you guys got that. Sir, -1 क्यों लगाया लेफ्ट -1? ठीक है, गार्गी सिंह, आइडियली राइट होना चाहिए. ठीक है, इसको इसको मैं कॉपी करके इसको फिर से एक बार लिखता हूँ. Okay, let me not add this 0 here. Okay, then what we will say here, uh, total will be equal to self dot right, and left prefix will be equal to self dot prefix left minus 1 if uh, left greater than 0, else 0. Okay, and then I will say total minus left prefix. Guys, did you understand what I did? See here, the problem was, I'll tell you. See, if this is 1, 2, and 3, and suppose the formula that we wrote here is that prefix of right minus prefix of left minus 1. I hope this you have understood. इसमें एक और वैल्यू ऐड कर देते हैं. I hope this you have understood. Now the problem here is that if the left is here, suppose if the left is here, okay, and the right is here, then the formula says that we will take sum of this one. So this is basically sum of this one total, okay, and prefix of left minus 1, which is basically everything which is on the left of 1. But if left is equal to 0, then there is nothing on the left hand side, so we need to have a 0 here. So what I did, when I did the prefixes, it should be 1, 3, 6, and 10. 4 plus 3, 4 plus 3, 7 plus 2 plus 1, 10. Okay, and I added one 0 here extra when I wrote the code first time. So I added one 0 here. That's why I did a right plus 1 and left minus 1 plus 1. So it became prefix of right minus prefix of, sorry, right plus 1, and this became prefix of left. Either you can do this way, or in the second time when I wrote the code, what I did not add the 0. Okay, but when we are calculating this, I said if I is greater than 0, then there should be one value, else this value should become 0. Either case you can, whichever one you want, you can do. Guys, please tell me if you have understood. Guys, we'll only do 2 questions today. uh, I wanted to do one more. So what you can do, you can try out one more question, which is I mentioned here. अच्छा, we did not mark it as done, so इसको done mark कर देते हैं. और एक और क्वेश्चन कौन सा सॉल्व किया था? 560. इसको भी डन मार्क कर देते हैं. इसको भी मैं शीट में ऐड कर देता हूँ. Guys, all of you understood? That's it for today. We'll wrap up. and we'll do more practice next Tuesday on. We'll do mix up of everything that we have learned so far, and we'll do mix up. There's one more pattern in arrays that I've not covered, which is intervals. We'll do that later. But in the next video, we'll probably start with linked list, and whatever patterns we have learned so far, we'll do a mixed practice also. Okay. I hope you guys found this session helpful. Please tell me. AI wala bro is saying, sir, please provide the sheet link. शीट का लिंक चाहिए. ठीक है, I'll put it in the chat, otherwise I'll put it in the description of the video on YouTube. Okay guys, we'll wrap up. Anyone has any question, you can ask me. I'll stay again. I'll stay for 2 more minutes, then I'll wrap up. एक और क्वेश्चन है इसमें, कंटिग्यूअस एरे वाला 525. यू कैन ट्राई टू सॉल्व दैट. ओके, आई विल सॉल्व इट नेक्स्ट टाइम. Okay guys, then we'll wrap it up and I'll see you next Tuesday 9 p.m. Thank you. Bye. टाइलर डडन, आप देख लेना वीडियो, आपको समझ में आ जाएगा. आप तुरंत समझ जाओगे. ठीक है. बाय गाइस, गुड नाइट.